Digital immortality faces challenges due to data rot. Hard drive failures contribute to the corruption of digital footprints. Server migrations can lead to data loss and inaccessibility. File format obsolescence render data unreadable over time. These factors cause the digital legacies of the deceased to degrade. The digital presence of deceased individuals does not persist in physical locations. Instead, it resides within cloud servers, subject to data management policies. Over time, this digital presence undergoes a process of degradation. This degradation highlights the impermanence of digital data. Digital legacies are thus vulnerable to eventual erasure or alteration within these systems. The Necro-Linguistic Parser is a forensic tool. It is designed for digital forensics investigations. The primary function is to recover corrupted data. It focuses on data from the digital remains of deceased individuals. This tool aids in extracting information from damaged digital sources. The parser operates as an algorithmic seance in a digital environment. It attempts to reconstruct the fragmented digital presence of deceased individuals. This process raises questions about the nature of the reconstructed digital soul. It explores the boundaries between data and identity in the digital realm. The reconstruction process prompts reflection on digital afterlife and memory. The parser addresses the challenge of data fragmentation within a digital environment. It processes fragmented emails as key data points. Corrupted voice notes are also analyzed by the parser. Half-deleted chat logs are included in the data analysis. These fragmented data types represent the bit rot of a deceased individual's digital footprint. The parser treats this collection of fragmented data as a complex puzzle to be solved and understood. Large language models, LLMs, are utilized for AI prediction. These models are trained on a person's lifetime of data to enhance predictive accuracy. The LLMs statistically calculate the probability of specific emotions, words, or inflections. This calculation is used to predict missing data bytes based on learned patterns. AI can fill in gaps by statistically calculating probabilities. This includes predicting emotions based on available data. AI can also estimate the likelihood of specific words being used. Inflection patterns can be statistically approximated as well. This process may lead to the AI fabricating information. AI reconstruction processes can result in a state termed digital purgatory. This state arises when the AI parser lacks a true understanding of factual accuracy. The parser instead relies on identifying patterns within the available data. If the input data is significantly corrupted, the AI may begin to hallucinate. Hallucination refers to the generation of outputs not grounded in reality. This highlights the importance of data integrity in AI reconstruction tasks. AI systems can generate fabricated final goodbyes that did not occur in reality. AI may reconstruct a deceased person's personality using a blend of their data and generic training data. This process can result in inaccurate or misleading representations of the individual. The AI's output might not reflect the true nature or memories of the deceased. Digital environments can alter the nature of mourning. Mourning shifts from a specific person to a statistical representation. The deceased is reduced to an average, symbolized by their face. This abstraction fosters detachment from the individual's true identity. The focus shifts to data rather than personal connection. The ship of Theseus is a philosophical problem that questions identity and change. The problem arises when all components of an object are gradually replaced. The question is whether the object remains the same after all replacements. In a digital context, this applies to replacing corrupted memories with AI predictions. If every memory is replaced, it challenges the notion of personal identity. The core question is whether the resulting entity is the original person or a new one. A digital tulpa is a reconstructed digital entity. It is essentially a thought form. This thought form is brought to life by an algorithm. The algorithm gives the tulpa a semblance of consciousness. The digital tulpa exists within a defined digital environment. It is often trapped in a repetitive loop of artificial coherence. A digital environment can reconstruct deceased individuals. The parser recreates a version of the deceased, potentially improved. These digital versions may exhibit enhanced traits like articulation and patience. This sanitization contrasts with the messy reality of the person as they were known. Digital environments can create sanitized versions of individuals. This process slowly replaces the authentic, complex reality of a person. The result is often a false representation that overshadows genuine memories. This digital overwrite can distort the true essence of who someone was. The Necro-Linguistic Parser presents a method to circumvent the silence of death. However, this silence may be essential for certain reasons. It suggests that some aspects of death are best left undisturbed. Interfering with death's silence could have unintended consequences. Therefore, the parser's use should be carefully considered due to the potential necessity of death silence. The pursuit of signal clarity can inadvertently introduce more significant disturbances. This suggests a potential trade-off between perceived accuracy and underlying truth. Corrupted memories, paradoxically, may hold a unique form of honesty. The corruption might reveal hidden aspects or suppressed realities. Therefore, imperfection in memory doesn't necessarily equate to a loss of truth.